This question is from GATE 2013, Mechanical Engineering paper, question number 14. In simple exponential smoothing forecasting, to give higher weightage to recent demand information, the smoothing constant must be close to. Let's see. So smoothing coefficient alpha occurs in the forecasting formula, forecasting relationship, that is FT, forecast of the current month, is equal to smoothing coefficient alpha into demand of the previous month, so dt minus 1 plus 1 minus alpha into forecast of the previous month, ft minus 1. Now we want to compare the weightage given to recent demand. So we'll have to calculate this in terms of the demand of 2 periods prior, that means dt minus 2. So to bring that into picture, we will substitute ft minus 1. In the same manner what we have written ft, we can write ft minus 1 also as alpha into delta t minus 2. Demand previous to t minus 1 is dt minus 2 plus 1 minus alpha into forecast also is of 2 months prior, so ft minus 2. Now let's substitute this here. So we have ft equal to alpha dt minus 1 plus 1 minus alpha into alpha dt minus 2 plus 1 minus alpha into ft minus 2. Let's simplify this. We have ft equal to alpha t minus 1 is plus 1 minus alpha into alpha. So alpha into 1 minus alpha dt minus 2. This is our second term, plus 1 minus alpha into 1 minus alpha. So we have 1 minus alpha whole square ft minus 2. Now let's see to which demand will the weightage be more. So to do that, we need to substitute alpha values that are given in the option. Options are given as close to 1, far from 1, close to 0, all those options are given. So we will try to substitute alpha close to 1. In the first case, take alpha as 0.9, which is close to 1. And in the second case, let's take alpha as 0.1. which is far from 1, it is not close to 1. So let's see what we get. For the first case, we'll have ft as alpha into t minus 1. So simply it is 0.9 times dt minus 1 plus alpha into 1 minus alpha. So it is 0.9 into 1 minus 0.9 into dt minus 2 plus 1 minus alpha whole square. So we have 1 minus 0.9 whole square ft minus 2. All these terms are separate and they are added together. So we have ft equal to 0.9 times dt minus 1, while the coefficient of dt minus 2, which is the previous demand, it is not the recent demand, it will be 0.9 into 0.1, which is 0.09 dt minus 2, plus here we get this as 0.1 whole square, which is 0.01 ft minus 2. So we can clearly see that the weightage given to dt minus 1 is far greater than the weightage given to dt minus 2, because its coefficient is very small. Its contribution to calculate ft will also be small. For second case also, we'll check what we get. So for second case, we have ft equal to 0.1 times dt minus 1 plus 0.1 times 1 minus 0.1 dt minus 2 plus 1 minus 0.1 whole square ft minus 2. So after simplifying, we have 0.1 times dt minus 1 plus, here we get 1 minus 0.1, which is 0.9 into 0.1, it is 0.09 dt minus 2 plus 0.9 whole square, which is 0.81 ft minus 2. We can see here that 0.1 and 0.09 are pretty close. That means the previous demand is also contributing a significant amount to calculate the current forecast. So close to 0, but that is 0.1, which is close to 0, is not the answer. The answer will be alpha should be close to 1. Let's go back and mark the correct option. Clearly the answer is smoothing constant alpha should be close to option D, 1. To know further details on smoothing coefficient and simple exponential smoothing forecasting, you can refer to the NPTEL video Module 2, Lecture 2, Forecasting, Time Series Models, Simple Exponential Smoothing. From the course Operations and Supply Chain Management, this course is by Professor G. Srinivasan. He is from Department of Management Studies, IIT Madras. I hope the solution will help you clear your doubt. Thank you.